What's going on, everybody? So let's talk about velocity and cars. All right, that's what we're going to talk about today. Okay, so this video shouldn't be long. I hope not. Let's kind of go here. All right. Now, so when it comes on to velocity, we all, well, the adults in the group, travel by car, travel by bus, travel by train, and things accelerate. Yeah. Now, before I go to acceleration, let's just talk about what it means to be calculating your speed. Okay. So speed is how fast I'm going, right? And so it's a measure of how far I have traveled, so my distance, and then how much time did I travel that distance in? So it's something like I traveled 50 kilometers in, I don't know, 10 seconds, right? Something like that, all right? So speed is a measure of how far you've traveled, your distance, in respect to how long it took you. I hope that makes sense to everybody, yeah? Now we're used to saying, well, over here in America, we say miles per hour, and thing is kilometers per hour, we say in British system or in the Caribbean, right? So that's kind of, when you tell somebody that they have a good sense of how fast you are going, all right? Now, the formula for speed is, and this can be speed or average speed, is distance over time. This is something that I want you guys to make a note of. Distance over time, all right? So if I wanted to ask you to find my distance, then, and say, for example, you're traveling at, it's hard for me to do kilometers. Say, for example, your speed is at 60 kilometers per hour. Yeah. And I said that you traveled you went on a road trip and you traveled 210 kilometers. And I ask you, can you find how long it took, which is time? How long is time, right? So if you notice here, just like with every formula I've been teaching you guys, you're going to be looking at what do I know and what am I trying to find? So if I look at the speed equals to distance over time, let me put it in a different color, right? Speed, average speed equals to the distance I traveled over my time, yeah? So what does it mean to be 60 kilometers per hour? Every hour, I'm going to travel 60 kilometers. That's what it means there. So when you're saying this to people, that's my speed that I'm traveling at, I want you guys to understand what it is. All right? It's like this. In 1 hour, you travel 60. In another hour, so in 2 hours now, you're going to travel 60 plus another 60, which is 120. So every hour, you're traveling 60 kilometers. That's what it means, okay? Now, let's kind of go through it. So the speed that I'm traveling at is 60. So I'm going to put 60 there for speed. Once I know speed, I change it with the speed that I'm going at. Then it says the distance that I'm traveling for my trip now, my road trip, is 210. So I'm going on a road trip. I said to myself, I said to everybody, I'm going to be traveling at 60 kilometers the whole entire way. All right. So then to find how long, I'm going to search for my t or my time. Now, we learned something in class. When I have a fraction equal to a fraction, what do I want you to do? Cross multiply, yeah? So what am I talking about here? We're solving for what they asked me for, time, how long it took. So I'm going to make this a fraction by putting it over 1, and then I'm going to cross multiply. So it's going to give me 60 times t is 60t equals to 210. To find t, I have to divide by 60 because it's multiplying. What I do to one side, I do to the other. My time would equal to that, whatever that is. 3.5 hours is what it would take me. 3.5 hours. That is how long it would take me. If I was traveling at 60 continually for my whole trip, it would take me 3.5 hours to get to my location, which is 210 kilometers away. All right. So this is one example of how to use the speed formula, right? So if you notice, you ask yourself, what do I know and what am I trying to find? All right. So how that makes sense? Yeah. So that is the introduction to speed. Now let's go and use it. Let's see if we can go and use it now. Where is it? There we go. So this is the January. This is the boot camps thing that I sent over. And then this is the January 2020 past paper. So let's go through a past paper together. All right. Now, they said the speed time. So you see speed on the y-axis right here, measured in meters per second. So it's telling you how much meters I traveled every second. Just like how I said kilometers per hour just a while ago, it's telling me I'm traveling this amount of meters every second. So if I wanted 3 seconds, it would have been the whatever they have times 3. All right. Now, not trying to scale shows a 3-stage journey of the car over a period of 40 seconds. We saw the 40 seconds here, 40, and the time is measured in seconds, right? Now, when they say 3-stage journey, let's make sure we understand that. If you notice it looks like my speed is going up. It's going up here in stage number 1, isn't it? Right? So in stage number 1, we're showing an increase in speed. It's coming from 0 meters per second because why? Think about it. A car, when you put it in, when you're just going to the car, it's not traveling at anything. So it's traveling at a speed of 0. So then when you start to put it in drive and then you slowly accelerate, it's going to increase in speed, right? Then we meet our top tier or our maximum speed here at 12 meters per second. And we'll kind of stay there. We'll put it in cruise control, all at stage number 2. So the car not going to increase and not going to decrease. It is going to remain at 12 over those time. And then here, maybe I'm approaching my destination because I start to decrease my speed in stage number 3 until it goes down to 0 again, which means the car shut off. It then a park, it then a neutral. We reach where we need to reach, yeah? So I hope that makes sense. This is what I'm talking about with everybody. Don't just read it bland. Try and throw yourself into the information, make it come alive for yourself. So we went on a 3-stage journey with this car. I hope that makes sense, yeah? Now, let's kind of talk about some things about speed again, right? So let me kind of scroll down. I could ask you a question like this, everybody. Well, I'm not ask that yet. Let me go to what they asked. It said, determine the acceleration of the car for each of the following stage, each of the following stages of the journey. I see stage 2, they want to know the acceleration. I see stage 3, they want to know the acceleration, right? So let's pause. Let's pause. We have to talk this thing through. What does it mean to accelerate? So speed equal distance over time, write it down. Excuse me. All right. Now, acceleration. If I'm accelerating, Claudia, Sharida, Zahai, Alana, if I'm accelerating, that means that the speed I was going at before is smaller than the speed what I'm going at now. So say this was time 2. All right, let me just use time 0. No, I don't use time 2 and time 4. My speed has to be larger than what the speed was initially or before. That is showing that the car is accelerating, okay? Now, everything in maths is all about a formula. So acceleration is saying this, everybody. You want to know your speed at the point that you are at. So I'm going to say speed. What do you want me to write here, everybody? Ending speed. Let me say it like that. ending speed minus their start speed all over. How long did you do that? How long did the speed take to change? Okay, so it'll be my ending time all over my start time minus your start time. Okay, that's what acceleration means. Okay, so say for example, I was traveling at 20 kilometers per hour at a time at time 10, right? So at time 10, my speed was 20 kilometers per hour, all right? Now, I'm traveling once again at 50 kilometers per hour at time, say 15. So what happens here? I'm telling you my exact speed at a particular point in time. So at time 10, I'm traveling at 20 kilometers. At time 15, I'm traveling 50 kilometers. Now, if you notice, my speed went up because it went from 20 to 50. Yeah? Now, what I said here, if I wanted to calculate my acceleration over that time period, what's that time period here? From time 10 to time 15, that's a time difference of 5 hours. Okay, 5 hours because it's hours we're dealing with, right? But remember, it can change based on the question. So I will take my time at the end, 50 minus the 20, all over 15 minus 10. So that's going to give me 30 all over, what's that again? 5, I think, yes. That's going to give me 6. So my 6 is representing my acceleration every moment per hour, put it that way. Every hour, I'm accelerating or increasing my speed by 6. That's what it's kind of saying to you, all right? So this will be 6 kilometers per hour, and I think it's squared. All right, that's a unit, something like that. Okay, so what does this mean? It means here every hour I am increasing my speed by 6. Okay, so I was at 20 before, and that's at time 10. At time 11, what's my speed? I'm saying it's accelerating by 6 every hour, So then my speed at time 11 is going to be 26 because it's going to be 6 more. Then at time 12, it's going to be 6 more on top of time 11, which is 32. At time, 13, it's going to be 38. And then at time 14, it's going to be 44. And then officially at time 15, it reaches to the 50 that I just told you. So every moment in time, it's being accelerating by the same amount. Okay? So that's what acceleration tells you. All right? All right, so I hope that makes sense. Now let's go into the question. Now in stage 2, are we accelerating? Do you see a change in my speed? Let's look at it together. So at time 16, my speed is at 12. At time 17, because 17 is here, 18 is here, 19 is here, all the way to 31 is here. All of those times are there, and that is not going to put it, right? I'm going to read up to my graph. Where does it hit? It hits right here. My speed is still 12. My speed is still 12. There's no change in my speed here, everybody. My speed remains constant. It remains the same. So acceleration demands that there is a change in our speed. So if there's no change in the speed, then you have no acceleration, right? So in stage number 2, there's no acceleration. Acceleration, there you go. If you want to put a calculation, you can show them that you know what you know. What I mean by that is, I look between at stage 2 and I grab 2 points. So in stage 2, I can grab the point at time 16. So time is 16. My speed is 12 meters per second. Boom. Meters per second comes here. That's the units. Okay. At 16 seconds, that's the seconds here. Now, and then at time 32, that's 32 seconds. I can grab another point in stage 2. My speed is still 12 meters per second squared. Right? So if I wanted to use my acceleration and show off, then I could say 32. No, sorry. Let me undo that. I can't undo. I'm going to grab my change in my speed. So 12 at the end minus 12 at the start, all over the time at the end, 32, minus the time at the start. So that's going to give me 12 minus 12 is 0. 0 over 16. That's going to give me an acceleration of 0 meters per second squared. Meters per second squared. All right? Okay? Now, what did you just learn there? Accelerations, the change in your speed over the change in the time that you have. So when there's a flat line, like a speed time graph that they give you, you notice this one is from a past paper. The one I gave you on a worksheet is from a past paper. So that's why I'm making sure you guys are empowered to know how to calculate acceleration and how to read the speed time graph. All right. So the speed here, no acceleration. My acceleration is 0. Now let's go to stage number 3. All right, so I'm gonna try and erase. Boom, 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 boom. This video is only about speed and time and velocity. All right, not velocity, speed and distance. So stage 3 now. We want to get these 3 marks in the people. We need to get the 3 marks. Now in stage 3, what's happening to the car? The speed is going down. This is measuring speed, people. So it's coming down from 12 and it's going down till it reaches 0, which means I'm more likely in park. I'll park up my car right here. Yeah? So they want to know what's the acceleration in that time. So we'll say, all right, boom. What Mr. Sean say again? To figure out the acceleration, I need to know what's the speed at the end and what the speed at the start. So I'm going to look at stage 3. The speed at the end at time 40 is at 0. So at time 40 seconds, the speed is 0. At time 32 seconds, this speed that I was traveling at that time was 12 meters per second. So I'm using these 2 points here. And that will give me, based on the same calculation again, right? So acceleration equals to what? The change in the speed. So I'm going to grab my ending speed, 0, minus my start speed, 12, all over my beginning time. I mean, my ending time, sorry, 40. Sorry. I just blanked out this a while ago. Minus my start time, 32. I'm going to go calculate it. 0 minus 12, that's negative 12. All over, what is that? 8, I believe. So that's going to give me 1.5. So negative 1.5 meters per second squared. Why is it negative? There's no negative at the bottom to cancel the negative at the top, so it remains negative. 12 divided by 8, 1.5. Now you get a negative answer. What does that mean in speed? Think about it. If I am increasing speed, that means I'm accelerating and my answer is positive. If I'm decreasing my speed, and that means I'm decelerating my vehicle, so that is why your acceleration is negative, okay? So your acceleration is positive when you're increasing your speed. When your acceleration is going to be negative when you're decreasing your speed, all right? Pause the video, rewind it. I hope it makes sense to everybody. Speed equals the distance traveled over time. Write it down. Acceleration equals to the change in the speed. So my ending speed minus my starting speed all over my ending time minus my starting time. So it's going to tell me how much my acceleration is. Logically also think about it to yourself. If I'm increasing my speed, acceleration's happening here. Acceleration's happening here because I'm increasing my speed. You notice the speed is going up in an upward direction from left to right. Then when I see my speed flatten, there's no acceleration because the speed not change, right? There's no acceleration. And then in stage 3 now, that's what's called deceleration. You can't spell it, but you guys just go Google it. Deceleration, all right? Okay? Or a negative acceleration, okay? And that is the gist of that. Now, let's go to another one. Ready, set, go. Leela cycles along a path for 5 minutes. Okay? Now, first, I look at my graph. You see time down here? Put the thing. Time, and I see speed. If you notice, same time and speed, meters per second. You notice two different exams, similar thing they test. Okay? So they are creatures of habit. You guys have to just remember that. CXC is a creature of habit. You just have to test yourself on what they like to test. All right? And who is texting me? All right. She starts from rest. What's my speed at rest, everybody? If my car is at rest, is it moving? No. So my speed is at 0. Right? At a constant rate until she reaches a speed of 5. So I have to look for where does my speed reach 5, right? Or so. Yeah? And then now, so she accelerates, you know. What does accelerate just mean? What will I just tell you? The speed is going in an upward direction. That's what the acceleration means. Now we have to figure out, yeah. So it says the speed is 5 meters per second. Is going to reach at 100. So at 100, I'm going to time being 100. So time is right here in the y in the x-axis. This is the y-axis. I go for my time being 100, and at 100, it's supposed to reach a speed of 5. So let me put a little dot here. That is where it's supposed to reach. So between here, where it's at rest, Claudia, Zahai, Sharida, and Lana, all the way to here, I need to show that it went upward towards that point because it's accelerating. And that means that my speed is increasing. Yeah? So, boom, let me take that out. Now, we got to figure out what we have to figure out here, everybody. We have to figure out how we're going to draw that line. Okay? Now, I don't know if this says sketch. Did it say sketch? Let me see first. Before I'm going to read any further. She can't, well, you know what? I think I need to actually do it. Yes, we need to do it. On the grid, below, draw a speed graph to show her journey. All right? Now, I'm not sure if CXC is very particular about how it's drawn. That's kind of the thing here I'm thinking about. Okay? Now, we're going to zoom in on this. Remember, it says constant. Constant means the same amount every time. Constant just means the same amount every time. So she's going to increase her speed. Her speed is going up to 5. So we have to figure out what's called the slope. Okay? All right. So if you think about it with me here, we're going upward to 5. So from here all the way to here, 5. And we're going across by 100, right? So I'm going to put 5 over 100, which gives me, I don't want to do that. Actually, let me pause. I don't want to do that. I don't want to complicate anything. It's hard to do this one. I want you guys to zoom in, kind of take in when we start linear lines. Yeah, I want to do it there. I'm going to give you a sketch for right now. I'm not going to give you the actual thing, but basically it's something like this, right? That's showing the first leg of her journey. She starting from rest, accelerating by increasing in speed until she reaches her maximum speed of 5. Then she continues cycling at that same 5 for 2 minutes and 40 seconds. Now, if you notice, what is time measured in at the bottom? It's measured in seconds. And you notice I try to complicate it by giving 2 minutes and 40 seconds. Well, what is 2 minutes and 40 seconds? How much seconds is that? Right? 40 seconds, right? 2 minutes, 60 seconds make 1 minute. So if we have 2 minutes, then we have 120 seconds. And then it says 2 minutes and 40 seconds. So we have to add the 40 seconds to that too. And I'll get 160 seconds. All right. So let's pause. So she accelerates here in her first segment. Then she remains cycling at that 5. So her speed not changing. It's going to remain the same. It's going to be a flat line as I go across on this bolded line, flat line. Now, how long is it going to be flat like this? Well, from here, this 100 second mark, we have to add 160 seconds to it, and that will give you 260. And that is how long she's going to keep going at that 5 meters per second. This is drawn terribly. I don't have a ruler, everybody. But basically, this bolded line is what I'm drawing on all the way over here. So her speed does not change in that segment, okay? And then she decelerates at the constant rate until she stops. So then she decelerates until she stops. Now that I reflect on it, I don't think they're going to grade you for the line not being, what's the word here? Truly accurate, because they did not tell me how it decelerates. And that's telling me they just want you to sketch it, okay? So this is exactly how they want you to sketch it. I increased from rest all the way up until time 100. And then my speed at that time was 5. That's what they said. Then I stayed at that 5 for 2 minutes and 40 seconds, and it's your responsibility to convert it into time, which is in seconds. So we calculated that to be 160. And that gets us to over here. Then it decelerates from there, and you get your 3 marks. Okay? So I hope that's helpful for everybody when it comes on to this speed question. It's been kind of tested a lot, so I wanted to make sure that I touched on it. All right? So stay tuned for the next question. It's going to be a walkthrough on set theory. All right? So later, have a good one. Keep on studying. That's all I ask. All right? Bye-bye.